So, given the ability to make functions to bring inputs and outputs, let's re-examine this Fibonacci loop demo. So I'm going to run this again. We saw this at the beginning of this segment, and let's say I want 5 Fibonacci numbers. So that works very nicely. It would be nice if this was a function. So let's make a new file, a new program. We're going to call it fibs functions.py. And let's say we're going to make a program that does this. We're going to have our function definitions, and might as well go ahead and put in, since this is going to be a bigger program, we'll go ahead and py programmer Garner. Okay, so we've got our comment header, and then we're going to have our function definitions, and then the main part of our program. And what we want to do here is we want to display a header, and then what we want to do is get number of fib numbers from user, and then we want to calc fib numbers, and then we want to display number results to user. And then maybe what we'll do is we'll ask do another. And here we'll start our loop. And when I'm doing something like this with a loop, I will just tab in this part that's going to be part of the loop. And then down here we will display goodbye. So that's our pseudocode. That's what we want to do. Note that, up till now I haven't done anything other than written some comments. But mostly my program's laid out now. I know pretty much what I'm going to do. So let's start with the header. I'm going to make a function, define display header, and this is just going to be print welcome to fibcalc. This program will calculate Fibonacci numbers for you. And so I write and you can see my pseudocode lines very closely with my function definitions. And I can write a little bit of code and test it. Welcome to FibCalc, this program. Okay, so I'm getting that. I want to put in... Yeah, there we got the nice little space at the bottom of that so that it doesn't collide with everything else. And then we're going to start our loop. So this will be a while loop, and I'm going to use that while true idiom. So and when I do a something like this, we could use a while true idiom, but since it's it's at the end, maybe what we'll do is we'll do something like this: do another equals y, and we'll just say while do another equals y, and we'll loop. Now what this does is it initializes do another to a y value, and then it will and then down here we'll ask if we want to do another. We'll say do another is equal to input do another question mark. Yes, no question mark. And so notice I haven't even put this stuff in. I'm going to put my do another loop in, and I'm going to test that. Do another, oops, down here. Yes. Do another, yes. Do another, yes. No. Okay, it looks pretty good. Let's try this. Do another, yes. Oh wait, if they type in yes, I mean, yeah, it's not that. Well, why don't I do this? Let's, all we care about is really the first character. So I can do that by putting a 0. So this will actually just get the first character from do another, and it'll just look at that. So watch what happens when I do this. Do another, I can put YES, and I can put Y. Yeah, all of those will work. However, if I put capital YES, it fails. Well, how can I fix that? Well, what I could do is I could dot lower this. And often we will lowercase when we're comparing things, we'll put a lowercase on the right, and we'll lower the user input. So this makes this not case sensitive. So watch what happens. Well, so now I can put Y. I can put YES. I can also put capital Y, and I can put capital YES or YES, and all of that will work. So now we have a nice, robust way of getting input. Of course, there's another thing that could happen, and this is why we test, right? What happens to a person that accidentally hits a space first, then puts a Y? It stops, and they're confused. Well, what we can do is before we do this, we can do .trim. So we're going to trim. So what trim does is it gets rid of any leading or trailing spaces on the do another. And then we're going to take the 0th element of that do another, and then we'll get lower. So watch what happens now. So we can put Y. Oops. Let's try again. Strip, I think, is different languages have different terms. So okay, so I can put Y. I can put space Y. I could put space yes. And these are all working. And as long as it starts with a Y somewhere before here, this is doing a lot of stuff to clean it up. And so we're cleaning up the user input. And and so you can combine function calls or method calls like this by just do another is a string. Strip is a method that works on strings, which gets rid of the spaces before and after of my string. Strip returns a string, so then I can use indexing to get the first element of that. And then, since that's a string, I can use the lowercase method. So the neat thing about these methods is you can keep tailing them on, and they will do neat things like this. In this case, we're using it to get our do another. So, why do we go through all that? Well, because this cleans up our input. Now, this is kind of messy as well. Is there another way that we could simplify this? Yeah, you could. You could actually define a function called do another. And this will be a function that will make this return true or false. And what we'll do is we're going to I don't want this to be the same name as the function. It makes it hard to read. I'll just say another. Actually, I'm going to say user response is equal to this input, and then I'm going to say another is equal to user, and then I'm going to put this test in it. So what's happening here? I'm going to take whatever they give me, I'm going to look at the first character after I strip and do everything, and if it's equal to y, another will be true or false. And then what I'm going to do is I'm going to return another. So this function, and just one way you can also comment a function is putting a string right after the define line, and using 3 single quotes to do it. So with these 3 single quotes, this is called a documentation comment. And what I'm going to just say here is ask user if they want to do another, and returns true or false. So documentation comments like this are nice because they give, we could do it with a comment ahead of it, but these actually have some nice uses here. So now I don't need to do my do another this way. And I'm going to use the while true idiom. So now we have an infinite loop. And I'm going to say if, and the neat thing is I can, so we see here that asks user if they want to do another and returns true or false. So if I put this comment here, if I want to remember what I have, that documentation comment here tells me what this function does, which is really nice that I just wrote. And I know that it returns true or false. So if this returns true or false, then I can say, in this case, really what I want to say is if not do another, then break. So this now says, if I'm not going to do another, then break, otherwise it'll keep looping around. And let's see what this looks like. Do another, yes. And so we can see that this is, now I have my do another, and I've abstracted this out. This is a pretty clean, way of doing that. And I've gotten all the mess about doing all this up in my do another, and I've got a nice clean do another loop. So this is a nice way of simplifying your do another loop. So, and this is using an example of a function which returns something and takes no parameters, because we're going to ask the user for information and then we're going to process that. Now we've got now that we've got this, well, what could I do next? And often, maybe I'm not going to do everything all at once, or I'm not necessarily going to code this all in the same order. Maybe what I'll do is I'll do the easy things first. So I'm going to define a function that is display goodbye. And I'm just going to, I might be more elaborate, in other places, but I'll just say, thank you for using my program. and then I'll run that. Oh, I didn't call the function, so it's not going to work. I've got to call it here, and then I'll run it. So, welcome to FibCalc. This program calculates Fibonacci numbers for you, and you know it's not doing anything yet, so it's gone through here. And yes, okay, so when it got to the end, it displayed the goodbye message. And maybe I want a blank line ahead of it so that it'll skip a line before it says thank you for using my program. And maybe I want one afterwards so that it'll make it clear. A lot of times you want to put some space between things. Okay, so now we've got a nice header function, nice goodbye. We've got to do another. You know, these are things that are probably pretty common to most programs. It's probably not a bad template for startup for a program. You know, you could like make that and save that as it is, and then you could use that for a startup. In fact, maybe I'll, you know, I could do a save as. You know, now I could have that in the future. I could copy that, and that would be where I would, you know, I'd start. And, you know, really, actually, with the program template, I could just change this to do stuff. And I'll put some placeholders in here just so that, you know, in my template version, you know, it's not specific. Yeah, so there I've got, you know, a template. I'm going to save that. Then I'll go back to my program. So that could be useful later on. All right, so I'm going to start my, now I need to get numbers. So again, we're going to define a function. Get number of numbers. How about that? And from user. So again, this one's not going to have any input, so no parameters. But I'm going to say num is equal to int. We don't want any. We can't use half numbers. Input. Please enter number of numbers you want. And then we're going to return what we get. And then here we're going to say of numbers is equal to get number of numbers from user. So we're calling that function. This function has no parameters, so it's an empty parenthesis set here. We're using the name of the function. And we have, if a function has a return, you almost invariably have a variable which is catching the result of that return. So I made a variable to hold the result of that. And maybe for now I will just do a temporary, you know, down here I'll just say print So I'll just print this so that we can see if we're getting the input we think we're getting. So I'll run that. Please enter the number of Fibonacci numbers you want. If I say 5, you ask for 5 numbers. Okay, so now I've established that, all right, I'm getting the number of, this is coming in correctly. Now I can do my calculate function. Well, let's see. We already had a program that did this, and we could probably just take this piece of this program, and we'll go to our Fibonacci sequence, and we'll make a function here. And we'll call it calc Fibonacci numbers. And we're going to need an input for this calc function. So a calc function, typically a calculation function, is going to bring some inputs, do something with those inputs, and return a result. So I'll bring that in, and let's see. And then I'll just paste this code in here. I need to indent it so that it is a block of code underneath this function. And let's see what so we got our 0 and 1 num numbers is here. Okay, so we use the, since my parameter name is the same as what was in here, we're going to then loop through this. And remember, we had to subtract 2 because we start with 2. This keeps appending. And so at the end of this, we have, this keeps appending to fibs. So what we need to do next here is return fibs. You know, so in this, you know, sometimes it's, you have to figure out what is it that I'm actually returning. You know, so I'm return the list. And maybe I'll put a dot comment in here. Given number of numbers returns that many Fibonacci numbers. So, you know, there we have a documentation comment. And, you know, while we're doing documentation comment, you know, displays header for fib program. And then, let's see, here's another one we can put some documentation comments in. Integer from user representing number of fib numbers wanted, fib numbers desired. And you realize these are just strings, there's no print around them. They are just documentation comments. They never show up to the user. They're just there for us as programmers to know what this function does. And then this one would be displays goodbye message to user before end of program. And we'll see, you know, there's our documentation comments showing up next to our functions. So it makes it even better documentation. So now, we will need a variable to collect the result from this calculate, and then we're going to call that function, and we can see calculate Fibonacci numbers. It needs a variable for the given number of numbers. So we need we're going to bring in number of numbers. So we're going to pass in this variable that we got, and this will calculate the fib numbers. And then we'll say numbers are, and then we'll use some curly braces. And maybe we'll break this up. We don't need this all on one line. I'll just put this in another print statement. F your numbers are fib numbers. Something's off here. Oh, I started with a single quote, so I've got to finish with a single quote. Okay, so there we go. We're going to display our results. Let's run that. How many numbers do I want? 7. I got 7 numbers. 3, 6, 7. Do you want to do another? Yes. Let's put 3. Yep, we got 3. And it ends. So we got a nice little program that's running. I don't need these comments here. I'm going to clear those out because my function names are clean enough. Actually, this could be a function too, right? This could be a function that just takes some values and doesn't return anything. So let's make a function that displays the results. Define display fib numbers. And we're going to need, so I'll just take this code here. I'm just actually going to cut this and just paste it in here. And so now we need these values in here. So I can just and so this will take in some parameters. We don't have a return on this one because we just wanted to display this information to the screen. There's nothing to send back to the program in here. But now this turns into display fib numbers, and we need to pass in, that's weird, let's see, oh, there we go, fix that. Maybe put a documentation comment in here, displays fib numbers to user. And then here we're going to bring in number of numbers and fib numbers. And let's try that. So now we have a function that does this. Okay, that's working. So I can clear this out. And now we see get numbers from the user, calc the Fibonacci numbers, put it in here, and then display those Fibonacci numbers. This is kind of, not great looking. So maybe we could fix that too. So rather than display it this way, maybe what we could do is say, maybe we'll separate them by commas. So we could, remember, we had this ability. We could say separating with commas dot join and fib numbers. So remember, the join function will take whatever the sequence is, put a semicolon and a space between them, and so now we will display this. Maybe put a colon here, and then maybe we'll put an empty line here to put an empty line at the end. So the nice thing about this function is now we can just kind of focus what's happening inside of this function, and it's separate from what's happening in here in our main program. And I kind of don't need that start loop. I know this is a loop, and I know that this is my do another question, so I don't need that comment either. So my main program's getting, and then I don't need to say, I mean, it's obvious that's display goodbye, and that's obvious that that's display the header. So I can, compress this up, and this isn't bad to read. Get number of numbers from the user, calc the Fibonacci numbers, display the Fibonacci numbers, and then, if not do another, break. So I can see the logic here, and my complexity has been moved up into here. So now let's see what this is looking like. Okay, so we have an error. So we can't join because the Fibonacci numbers are, they're not strings, they're numbers. So that's not going to work. So let's see what's happening with this join, why this isn't working. So I'm going to, in the terminal, I'm going to type Python so that I can get an interactive interpreter up. And let's say that I have a list 1, 2, 3, and we'll say LST is equal to that. And then I try to say comma space dot join LST. It doesn't work. Now if I had a list of strings equal to 1, 2, 3, and I did, and I joined that with comma, that would work exactly the way we'd wanted it to. That's what we wanted to have up here when we displayed it. So how can we fix that? Well, there's a neat function called map. And so we could say list 2 is equal to map string comma list. So we're going to take this list up here and we're going to pass it to this map function. Now let's look at list 2. Okay, so it's a map object. Well, it doesn't do much good. Let's try this. Let's see what would happen if we take list 2 and okay. So now if we convert this to a list, we get a list, but notice that rather than being a list of numbers, it's actually a list of strings. So let's look at the original list that we had, LST. LST was numbers. And so another way I could write this is say list 3 is equal to list map string comma LST. Then let's look at list 3. So I've taken this list of, and what map does basically says take this function and apply it to each element of this sequence. So it'll convert every single thing in here to a string. And then, since this produces a map object, I mean, what we want is another list, we can convert it back to a list, and we get back a list. So now what we could do is we could say that, the text that we wanted would be this comma space dot join this list map string LST, and then I gotta get all of these done, and then let's look at text. And they're taken my list of numbers and converted into a string with spaces in it. So this is a neat way of of combining a list of numbers and fixing that problem. So I'm going to take this and copy it, and then that's going to go here, but rather than list, I'm going to use these fib numbers that are coming in. So this will join, this will take the Fibonacci numbers that are coming in. It's going to map the string to each one, so we get a collection of strings. Then what we're going to do is convert that to a list, and then we're going to join it on this comma. And let's see what happens. Let's see, indentation error. Let me kill this and then try running it again. Put 5. And there we go. And we have a nicely displayed list, which looks better than having the square braces for the user. So there, we've produced a nice little program. And you see how now our main part of our program is actually very, very small. Display header, get number of numbers from the user, calc the Fibonacci numbers, display the Fibonacci numbers, do another, and if not do another, break, and then display a goodbye. So this is actually the full logic of our program, and it's very abstracted, and it's pretty readable without needing a lot of comments. All our complexity is abstracted away in these functions, which in themselves are not super complex. This one was a little bit more complex, but once you have the algorithm for doing it, it makes sense. And once and then we finally have it hidden, and we don't have to deal with it. You could use this Fibonacci number sequence anytime you need to in the future, and you wouldn't have to rewrite this piece of code. You could just use this function over and over again and copy and paste it into other programs, and it would work great. And then we have our display and goodbye functions. And so that's how our program goes together with functions. Thank you very much.